If you've mastered the disk method for finding volumes, you're now ready to learn the washer method. So here we go with an example. Let's look at the region bounded by y equals 2 and y equals 4 minus x squared over 4. So let's see what this region looks like. Y equals 2 is the horizontal line at the height of 2. And y equals 4 minus x squared over 4 is a piece of an upside down parabola. And that's the region that we're interested in. This region goes from -3 to 3. If you look carefully at where these two curves intersect, you'll find that they intersect at -3 and 3. And we're going to revolve this region around the x-axis. And notice that when we revolve this around the x-axis, it's a little bit different than the previous problem we did with the disk method, because when we bring this region around the x-axis, there's a big hole in the middle. It's a little bit hard to see what's going on in 3D, but what this 3D object looks like is a ball. This solid looks like a ball with a cylinder drilled out of the center. Let me write that down. We get a ball with a cylinder drilled out of the center. And what we want to do now is we want to find the volume of this three-dimensional ball with that cylinder drilled out of the center. So we're going to do what we have done in the past. We're going to take a slice of this three-dimensional thing, and we're going to remove this slice. And what we get this time when we remove a slice is not just a disc, but a disc with a hole in the middle. And this disc with a hole in the middle is what people in the hardware business call a washer. Here is a picture of some washers, and that's why we call this the washer method, because each slice looks like a washer. And notice that each slice has a big radius and a smaller radius, and so the volume of each slice is pi big R squared delta x minus pi little r squared delta x. And once we understand this formula for the volume of each slice, it'll be easy for us to figure out, first of all, what is the big R, what is the little r, and then second of all, we add them all up. We take the limit as delta x goes to 0, and the sum becomes the integral, and once we set up the integral, we can use our calculator to find the final answer. So before we write all of that down, let's take a look at this diagram and notice that the big R is the y value for the upside down parabola, and the little r is the y value for the horizontal line. Okay, the big R is the y value for the upside down parabola, and the little r is the y value for the horizontal line. Let's put it all together now. The volume of one slice, and in this case each slice is actually a washer. So it's a disc with a hole. It's pi big R squared delta x minus pi little r squared delta x, which is pi, our big R was 4 minus x squared over 4 squared delta x minus pi, our little r is 2 squared delta x. I can pull the pi out in the front and pull the delta x out at the other end, 4 minus x squared over 4 squared minus 4. And now add them all up. And take the limit as delta x goes to 0. And the sum becomes an integral. I have the integral from -3 to 3 of pi 4 minus x squared over 4 squared minus 4. And remember, when you take that limit, the delta x becomes dx. And once I set that up as an integral, I can go to my calculator and put that into the calculator, and the answer you get, I'll give you a second to try it on your calculator. Go ahead, pause the video and try it. Did you get the same answer I got? I got 42.075 pi. And if you math frac that, you can also give your answer as 1683 over 40 times pi. Either one of those two answers is correct.